In this series of videos, the idea is to create a machine learning model capable of detecting reflux events in medical studies of pH and impedance. This kind of studies, called dual pH multi-channel intraluminal impedance, are studies used for gastroenterologists for trying to detect or diagnose the gastroesophageal reflux disease. These kind of studies are actually really particularly interesting for detecting non-acid reflux events. Most of the content here are taken from this article of Mosa, Rosen, Woodley, Orsi, Armas, Faure, which is there, esophageal impedance monitoring for gastroesophageal reflux, of the Journal of Pediatric Gastroenterology and Nutrition. So what is the gastroesophageal reflux? It's the retrograde passage of gastric content into the esophagus. The retrograde passage of something is actually normal, so I think everyone suffered or went through something like this at some point. It's really common, but when this is actually really frequent and maybe with more than just something small, this can be problematic. So it can produce heartburn, regurgitation as a mild consequence, as a mild symptom, but then it can have some heavy consequences later. And this is actually something that happens with infants, so this is something that is diagnosed for babies. So actually they can suffer a lot from these kind of things. In the past, only pH monitoring were used with the catheter inside the esophagus and just detect when the pH level drops below 0 to detect that something went wrong there, something acid were in the esophagus, which it doesn't supposed to. Of course, this kind of detection doesn't detect non-acid reflux episodes. So for example, if you are with an anti-acid medication, maybe you can have some content going in the esophagus that it shouldn't be there, but you can detect it with this kind of measurements. And actually for infants, if they are breastfed with the milk or with milk formulas, this can actually avoid triggering the detection. So at some point the impedance were added. So basically it measured the change in the electric resistance of the esophagus, putting electrodes inside the esophagus, and this information together with the pH allows more information being detected, because you can detect something that is going on in the esophagus regardless of the pH value. You can actually measure the direction of the thing in the esophagus going up or down. You can determine also to which point the thing arrived, if it's until the mouth or in the middle, and even you can detect the kind of content inside, if it's liquid, gas or mixed. So of course this provide a lot of information for detecting, but also a lot of burden for the doctor for trying to analyze. These kind of studies are held for 24 hours, so the doctors have to check a lot of data to see when this event happened. So an automatic detection, of course, is really helpful for them. So the catheters are put inside the patient. This is the esophagus. I'm taking this image from this article of Paul and Tutuyan. So the catheter is made by 7 impedance sensors and 1 or 2 pH electrodes. These 7 impedance sensors provide 6 channels of impedance because they work in pairs. So you measure the resistance between these two things, these two, and these two. So you have 6, and the pH sensor, which is located here. In some cases you can have two pH levels located in different positions. So at the end you have a time series of 7 channels. 6 for impedance and 1 for the pH sensor. So the idea here is to have this time series and try to detect when the impedance level drop by 50% of the baseline in at least 2 distant channels, because that indicates that something has went up at least a little bit. So if the impedance drop in this channel, so something went here and something went here, so something arrived until this point, so there is a reflux event. Then of course, once we have detected this episode, we can classify according to the pH level. And the duration of this episode are around 1 minute, maybe less, maybe more, but around 1 minute of duration. I'm checking this information from this article. They say the people with the disease had around 42 seconds of median duration. Maybe we can extend it a little bit just to be sure, but we can expect an hour of duration of this kind of events. And of course, the automatic detection of these kind of things allows to avoiding manually review the 24 hours of the study, and of course increase the accuracy if the model works well as we expect. Then a bit later I will show how these events look like just in a Jupyter notebook. Let's start by creating a project from scratch. Let's create a folder. Let's put a Visual backend, hatch. Let's create an environment. Let's pin the Python version. And let's add some packages that will we use. For example, matplotlib, numpy, and I guess for now that's it. Maybe you can add numpy, and for the development part matplotlib, Python, Jupyter, and the complete thing for the notebooks. And probably that's it. Let's create a folder also for writing notebooks. Let's open the editor here, and maybe we are almost ready to start. So we have the data set in the folder, how to mount it, SG. We have the data set here with the complete set of patients, so we should be able to read from this folder. We have for each patient the numpy array with the time series and the series of events that we are going to analyze later. It's not only the series of events but also information about the study itself. Okay. Let's also add, since we are here, we add Pydantic just for having some kind of validation. Let's do quickly from base from Python import base model. Let's create a dataset path. Let's get config. We can do some JSON file in the home. Let's do, I think I have already that file. Home path, home. Okay. Yeah, let's do like this. Config path with open as config file. This is with not parse row match model. Validate JSON, I think. And then we just can return config if is exactly raise file folder. Let's create a notebook. Let's call it EDA to see what's going on. Of course, I don't remember how to reload the Jupyter notebook, so let's check it out. Reload Jupyter notebook. Oh wow. Okay. I don't know if this is okay. This is taking this thing. Python environment. Okay, everything is working. And let's install in editable mode our package. Okay, I guess it's already done. I think I have the file. Let's see if it fails. We have it, and we have the configuration there. So let's try to put some structure in the notebook. EDA. Let me write later an introduction. Import everything and set up the graphics setup. One thing that we can do since we are here is, for example, how many data we have, so we can start just, I don't know what title to put here. Let's see later. Maybe we can do, okay. Oh my god, create me a cell here, please. Okay. Config dataset path. Maybe we can do something like this. Patients list. We have this thing. Let's see how many do we have. 102. Let's put something like number of studies. Numerosity analysis. It sucks as a title, but okay. So we have this thing. Maybe we can write one function to read patient folder or read more than patient study folder. So we just, okay, I don't know what Copilot did, but it's not going to be useful. mpng array, and for now edict. I don't have the, okay, doesn't matter. From path leave import path, from typing import SMP. One thing that we can add also, we add the proof, right? I don't know if I have the plugin installed for roof. Yes. So let's do mp.load, I guess, is data .npy. Then we can do metadata path just to the folder is events.json with open return data metadata. Let's see if we can actually create some Pydantic object for this thing. So we have here from ph set.data import, no, let's not get data, read this to the folder. Let's see if we do something like this. We have time series, metadata. Okay, you're right. For the time series, we have 7 time series with this amount of samples, and then we have our metadata, which it will contain two keys. We're going to be the list of the events and the list of channels in the study. So maybe we can do class metadata or study information. We can put here channels, would be a list of channel, and then we events, with list of events. This is going to be base model. I don't know what is going to be here, but let's see later. And class event from Pydantic import base model. I am from typing import list. We can have a metadata, channels. We have time and the distance to the reference. So this one is going to be, at least for the impedance channel, the distance to the base of the esophagus, to the base of the stomach. So it's going to be, this is going to be the farthest from the mouth, is going to be the closest to the mouth. So we can try type and distance to reference as a field. Float. For this is okay. I put in the event. This is in channel, and then we can have events 0. Excellent. Start, length, and type. Okay, easier to write it. The start is going to be an int, length is going to be an int, type is going to be a string. So here we can just return this, and here we can create and validate JSON read. Okay, let's see what happened here. Let's remove the import. Okay, metadata. Okay, not bad. Okay, what I think I would like to do, since we are here and we can just plot one study to plot one study. So let's try to plot something to see what we saw, what we see, and then we can try to plot some event to see if actually the events make sense. So let's import matplotlib. Okay, let's run this. Let's do maybe we can create something like this, like a property here. Okay, no property def. Okay, good compiler there. Let's see, we can reload this. We can put something like this. Maybe no in channels 2, 3, I don't know. We can do something like this. Maybe we can put in the type and the distance to reference. Channel description is type. Maybe we can write just an F string and in parentheses it's not going to be unit, this distance to reference. We have here, we have this thing, legend, probably. Okay, if we're going to plot everything, it's going to complain about the legend position probably. It's taking too long. Yeah, we can stop it. Let's put to see if it works. Okay. Really good. They are for 6, 8, 10. Okay. And the last one is with pH. I would like to plot everything. Maybe not putting the legend, but just the title. Maybe it's going to be better. And then type layout. Okay, not bad. I think it's a bit too big for actually see something. Okay, not bad. Let's see some other. Number 5. Okay. We have the impedance channel and the pH channel at the end with some values. Of course, the values are not scaled. The pH should be in range of 4, 7 or something like that, even until 10. But we will scale it later for the machine learning model. Maybe we can create a function out of this and put it in a module. So it should be plot study. We will receive the time series, the metadata, which is a study information. Then we can copy everything. Okay, and we are going to return the figure. And another thing we can do is from to. Maybe we can actually it's not going to like from optional. Hold on to, let's put it and begin. Luckily this is not Pascal, so begin is going to be from typing import optional. Then we can reformat later if again exactly, and this is begin, and let's copy all of this, graphics.py, organize import, no, format document please. Okay, maybe the fixed size also can be a parameter, but let's go. I'm going to leave it here, and then we can delete it later because probably we are going to make more plots. Punto graphics import plot study. Plot study. Time series metadata begin. Oh, okay. Put anything. Okay, this is probably I have to restart the kernel. Let's open 102. No, this is because I didn't put here some optional things. Okay, now I have to restart the kernel. Okay, we have our study. Oh no, let's omit the output. Okay, did I put a show in there? No, just returning it. Okay. So it seems reasonable enough. So let's see if we can plot an event. So maybe for plotting an event, let's metadata punto events 0. Let's plot event. Okay, then we can. Should I need the metadata? Yes, because I would like to use plot study probably. What do we start? Plus left. This was begin and end. Okay, probably it's detecting. Let me omit the output. It's not a really good event actually, but probably detecting this peak and this restitution at the end as something that is going on. Or maybe it is a clear event. A sudden drop here, then a drop here, a drop here, a drop here, a drop here, and then the restitution of the levels of the impedance and a drop in pH. So maybe this is an event. Maybe we can actually put some more information here. This is fig subpt event.type. Why is everything? I should relay out. Yes. Okay, we have an impedance reflux. Okay, let's see if we see another event, for example 5. Okay, this is this one and this one, and probably drops here, so it didn't arrive into the mouth, just near the stomach, and goes up a little bit, and it's a drop in pH in that moment. So that's a clear event. Let's just check another one. Okay, also this one, we have also the drop in pH, but the drop in impedance until the last one, and then the return to the baseline. So this is what we are looking for basically. I don't know what are those kind of peaks, but probably because it's not a continuous thing, it was just a piece of something, gas or liquid, then nothing, gas or liquid, nothing, or maybe just noise. Okay, let's put this thing in graphics. Let's put some typing. I'd like to know what it's doing. There should be an event. One thing I want to see, and we should return this thing. One thing I want to see is what are the lengths of these events for the complete study, because I think I saw some strange things in the JSON. Okay, just for plotting something. What I would like to do is to see let's first of all event type. It should be 2 types of events, so maybe we can do, we have the patient list of the study list, we have this function. Let's see what we can do with this. For study in patient list, let's read it. Metadata. Okay. For event in metadata.event, event.type should be a much clever way to do this, right? If I count it, measure the pandas or polar. Okay, let's keep it simple. Event types. Then we can do this is going to be counts. What is this? Maybe we can do also oh, it's take a really long time. Okay, for my anxiety, UV we can finish. Okay, we have an error. It took too long. Maybe we can avoid actually reading the time series if you're not using it. So maybe we can just read metadata and you use it right here directly. Okay, great. Study folder. This will be study folder. Can do just something like this. Do like this. This doesn't have attribute events. Okay. We have our values and our counts. So we have basically this thing. We have a lot of impedance reflux events and a small number of pH reflux. One thing we can do is make a duration, even duration. I would like to do, okay, let's put it here, let's put it here. No, this is not duration, this is length. This let's put here. Okay, maybe it's too much. Distribution of event types is too much, the title, but okay. What I would like to do is the duration of events, maybe as for like box plot. Okay, so what do we see here? But there are two groups, so I don't think it actually makes sense. Oof. Okay, we have some clear things going on. Let's put by type. So at this point we can just use pandas. Okay, I can make the comprehension, and it's going to be easier. Okay, can we actually organize import here? Yes. For pandas as PD. Okay, this is horrible, so it doesn't help a lot to see something. Let's try to make a box plot here. Okay, we have something really strange. So one thing we can do actually is we have around 60 samples per second, so we can compute it from here. When we have this thing, maybe we can put, let's put it here, let's put here sample rate. We know that this study are carried out around 24 hours, so we can do sample has not attribute shape. Wait, this is a tuple. Read the study folder. Okay. We have 24 hours per 60 per 60. This will give our rammer around 50 samples per second, so this is what we have. So we can just use this as seconds, or maybe minutes. Let's keep it in seconds. Okay, it shouldn't last 40,000 seconds. 40,000 seconds. How many seconds there are? There 40. How many minutes? Okay. Clearly. Oh no. Okay, 11 hours of an episode I don't think is actually reasonable. But okay, we can actually analyze them. So one thing I would like to do, let's see then the outliers, but let's do like this. Basically this thing, let's do events, no, type, mention the type, unique, come on, impedance. This should be box plot. I guess it should receive a list. Good guess. Close. And then we can put. Okay, there are a few things reasonable here. So it is reasonable that the pH reflux are longer. Maybe it can be a case of a reflux episode of 11 hours. Maybe it's too much. But we are going to focus on this thing. So, oh, the big pointer in KDE. So we are going to concentrate in this one. So let's see if we can just plot this thing. Okay, there are a lot of outliers still. Okay, let's put the label. Impedance reflux. No, it's label. It's not label. It's like the second parameter, right? I should do like this. Why these labels? Let's put set y label, duration in seconds. Also here. Also here. Okay. Label. Complete set of events. There should be a way to do this without this, but labels. My God. I have to name it tick label. Okay, tick labels. Tick labels. Tick labels. Okay. So let's see if we can just make a summary. We can do something like this, right? Yeah, okay. In layers, set events df. It will be this thing. Oh, let's create the mask first. Okay. Duration. And 100 seconds, it would be true. Let's put a bit more, like, okay. The vast majority is around 100. Can I plot? I guess it will be helpful. AX line, or at least in maybe in the the median should be maybe approximated, right? Let's compute the median from the complete data set, otherwise here median duration should be pretty close. Okay, and we can create a legend. The legend. So we actually can see, okay, 36 seconds, so half a minute for the impedance event. There are a few really short ones. I am really skeptical about those one. And how many there are here, for example, without the strange ones, like some. Okay, they're not that bad. There are a few 60% of fill layers. With a reasonable duration. I think also a few minutes is reasonable. I don't think they are too problematic, but maybe we can take a look. Okay. How can we identify those that are problematic? Maybe when we are traversing this, we can create the patient files event IDs. Let's do an enumerate here. And then add more things here, basically. Here we can see okay, let's put outliers. Okay, maybe we can move here so it's not lost among the plots. So the whole preparation, we have this thing which is a bit terrible, separated by pH and impedance. Let's put some detail in here. Set title. All set events. It's not that bad. This done. 10 seconds. Okay. Let's see. Let's see this thing. Okay. Sort values. Setting false. For example, this one, patient 2, the first event of patient 2. Let's take a look. How do we do that? We should open this. We should take this and plot it. We have patient 2, but patient 2 should be position 3. This is sorted. This is not sorted. Okay, let's do. Wait, what? I have the complete whole path. Yeah, exactly. Maybe we can just do TF. So I guess the sorted is not going to make any harm. Nevertheless, I guess this is returning something. Yes. We can do. It's gonna be patient file probably, or study file. Let's put a study file. Study file, because it can be the same patient with 2 studies, so it's not a patient level. Study files, study file. Okay. So we have here, we have to be sure to, okay, let's, on the event of this study file, event ID, and it should be half of the study. See, exactly, this is I don't think this is actually right, because we see a drop here, but this is in terms of hours. We are not that worry about this kind of thing. But let's see, for example, the last one. Why do we have an error? Index 7. How many channels this thing has? 8. Okay, there are a few ones with 8. This is something I would like to check also, but why there is an error if we have from 0 to 7 for axis 0. No, I guess, but study, there is a 7 hard-coded exactly, and channels. And there is another pH channel. There are, probably this is meaningless, and we have 2 pH channels, but we have an event or something that can be thought as an event. Maybe it is not, but we have some drop here, but it's not continued here, or maybe this one is being detected as something small that is going up. So yeah, exactly, this for example is 100 seconds. I think is still completely reasonable. We should put probably 1000 seconds here. Okay, with 1000 we don't have that much. And this is completely wrong. 1000 seconds is, this is 15 minutes. Around 15 minutes. This is too much, I think. Okay, I will plot it later to understanding a little bit more what is going on. This is also, I don't think it's okay. Let's see, let's put, for example, 5 minutes is like 300. I think. So here, for example, I don't think it's a valid episode. There is something here going on, but it's from the top. Maybe here, and then here, and then here, but no, I actually don't see it. Let's see, maybe here, maybe it's something, but it's from the middle. But if I put, I'm sure if I put here 200, the last one is going to be probably valid or not. I think here I think something went wrong with the sensor, probably in that case. I'm not completely sure. Even with 200, they are a bit strange, to be honest. But 150. Okay, this is probably garbage. Okay, this is maybe, okay, probably this one, something went wrong. Yes, this is clearly something going on, and then appear a bit later in the other one. So at least something is going on there. Also here, maybe it's the same thing, or maybe we have repeated data. Another thing to check. Yes, these are a bit more. Maybe he's talking about this kind of thing, but I am not completely sure. Let's put, for example, okay, this is okay. This is much more clear. We have the peaks, the restitution at the end is a bit long, but still I guess there is a bit, everything is a bit saturated here. But when the duration is shorter, we have something. This is a bit noisy. I don't know exactly the direction of the thing, but maybe is a reflux. Probably not. It's dropping the restitution, or maybe this restitution at the end. There is another drop here, and then another. This is clear, This one. Drop, 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 drop. Great, so one thing that we have to do is to filter, at least to try to clean as good as possible, checking repeated studies that we have, and trying to probably cut events around, I don't know how many seconds. I will check in the literature to see if there is something standard to say, okay, it can last 11 hours.